OCSC test and a transformer. It's also known as open circuit and short circuit test. Short circuit test. Let us understand why this test to be carried out. First of all, open circuit and short circuit tests are generally performed in order to determine the circuit constants, efficiency, circuit constants, and regulation percentage regulation without loading the transformer. That means you are not loading the transformer. Without loading the transformer, still we are able to find out the major components are like efficiency, regulation, and circuit constants. And these results, test results, generally give us more accurate results than which were obtained by measuring on the fully loaded transformer. What is the advantage of doing this? The power consumption is very less and very small compared to your full load output of the transformer. So let us understand how open circuit test is carried out. What is the uses? So let us write the circuit for open circuit. So we are considering an wattmeter. We have voltage connected, voltmeter connected across. So this is your VI measured. So this is your wattmeter W1. So as we know, ammeters are connected in series. So this is your primary of your transformer along with secondary of the transformer. This is kept open. So generally LV side is connected as primary, HV side is connected as secondary. So as you can see here, the high voltage side is kept open. How to conduct the experiment is, here a voltmeter V1, this is your voltmeter V1, and ammeter A1 and a wattmeter are connected on a which side? Low voltage side, which is being supplied with the rated voltage. So we are going to apply the rated voltage and voltmeter reads the voltage of the primary. Since as I mentioned, secondary of the transformer is open circuited, a very small current I0 flows, which we can call as no load current in the primary. So after doing this, we will be able to obtain the power loss in the transformer, and by doing so the open circuit test gives us the power losses, or also known as the core loss. Core loss means your iron losses, and there will be no losses on the secondary. Hence the secondary, because the secondary is open, I2 is equal to 0. Now since the no load current, that is I0, is very small here, usually it will be of ranging between 2 to 5% of the full load primary current, we can be neglecting I square R loss with respect to primary. Hence the entire readings what we got, it is with respect to the core of the flux, and the flux sets up the rated voltage with which will have a normal value, so that normal core loss will occur. So this is same as your core loss at all the loads. So and the wattmeter which measures and the reading which is given is we call as overall core loss. So here what we will be able to obtain, we will be obtain like we will be getting Pi is equal to V1 I0 cos phi naught. So no load power factor cos phi naught is equal to PRW, whatever you want you can consider, V1 into I0. Similarly, we know the factors IW is equal to I0 cos phi naught, and I mu is equal to what? I0 sin phi naught. One is with respect to sin, one is with respect to cos. So IW is with respect to cos. Also we will be able to find out R0 V1 by IW and X0 factor we will be able to find out. So these are the circuit constants we will be able to find out with respect to your open circuit test. Now what is short circuit test? It is similar, everything will be similar now. So here we are having low voltage supply, our voltmeter is connected, So this is your ammeter connected in series, which is connected to a wattmeter, it's connected to wattmeter. But here the secondary is shorted or it is connected. We call this as shorting. Right? So this is your HV side, unlike post AC test. Here the LV side is shorted, HV, all the parameters are connected to HV side. Now what is the reason of shorting LV side? Because by short circuiting the LV side and taking measurements on the HV side, there are various reasons. We will list out one by one. First one is the rated current on the HV side here is lower than that on the LV side. So this current can be safely measured. Also we know that the applied voltage is very less, that is 5%, because here the maximum current we are applying, the voltage is less of the winding. So what happens here? 5% of the rated voltage of the winding will be greater accuracy with respect to the reading of the voltmeter, and it is possible to get very good accurate results when the HV side is used as a primary. So how the test is conducted here? As usual, here while using an auto transformer, we will supply the rated current. So we have to calculate the rated current depending upon the kVA rating of a particular transformer. If it is a 2 kVA, 5 kVA, 10 kVA, depending upon different kVA transformer, the rated kVA, that is full load capacity of a transformer, will be calculated. So we will be able to calculate S is equal to VI by 1000. So let us imagine if S is your rating 2 kVA transformer. So how to calculate? So we know that it is single phase, so 230 volts. So I can be calculated. So if you calculate here, I is equal to 2000 divided by 230. You will be getting around 4.3 amps. So this is the rated current. So the rated current will be applied to the circuit and we will get very low voltage and the wattmeter reading. That is cos 5 wattmeter reading will be, unity power factor reading will be referred. So once we get the value, we will be able to find out WSC, RPSC, that is your V2, I2, cos phi 2 values. Similarly, as we did with respect to your OC test, the parameters with respect to the secondary will be known to us. So this is with respect to your OC and S.